Okay, so now let's look at some examples that have an a in front of the x squared. So this a might not be 1. Okay, so it could be ax squared plus bx plus c, or possibly ax squared plus bxy plus cy squared. It's the same technique for both. So when you're looking at this, you know what, for illustration purposes, let's do this one by decomposition, and then I'll show you a speedier method. So you might notice that 9x can be broken into 8x and 1x. And when you look at these pairs of terms, you get the same ratio, 1 to 2 in both. So that means that the factoring by grouping should work out. So let's factor out a 4x from the first pair to get x plus 2. Let's factor out a 1 from the second pair. And then you'll notice you have your factoring. Now what I want you to notice is, again, the x squared term came from the products of these x terms, 4x and x. And the constant 2 came from the product of 1 and 2, these constants. So, and then the 9 came from the sum of these two products, 1x and 4x times 2. So this method is a little bit slow. So instead what we're going to do is we're going to think about, well, it's slow because sometimes it's not obvious what the decomposition is. So instead we're going to do a smart guess and check again. We're going to say, let's actually peel apart both a and c into factors. 4 could have been 1 and 4, or 2 and 2. And 2 could be 1 and 2. So our idea is, let's pick some factors, try them out, see if I can get that middle term of 9. Let's suppose that our first guess for 4x squared is that it came from 4x and x. Let's also suppose that our first guess for 2 came from 1 and 2. Let's check the middle term. So you get 1x and 8x. That is equal to 9x, so that's correct. Now when you're doing guess and check this way, I want to point out a few things. So first of all, you'll notice that these terms have no common factors, right? So let's suppose that I decided to switch the order just to try it out. Okay, maybe it's plus 2 on this side and plus 1 on this side. Well, first of all, if you actually try this out, you'll see that that's not what you want. That's going to be 2x plus 4x, which is 6x. But more importantly, even before you do that, you can realize that it's not correct. Why is that? Well, when you do it this way, 4 and 2 have a common factor. So if this were correct, you should be able to factor out a 2 from that. But we were saying that it's not this original trinomial doesn't have a common factor. So that means it should never be possible to factor out a 2. Okay. So that's another technique that you can use to narrow down your choices quickly, is avoiding common factors if there's no common factors in the original. Okay, so I'm going to cross this out so that you know that it's not correct. Let's do the next example, same idea. Okay, so we know it's going to be, so when you have x squared and y squared and xy in the middle, it should be something times x and something times y in each of these. How do you figure those out? Well, again, you're going to factor the a and c's. So 5 you can break down into 1 and 5. And then 3 you could break down into 1 and 3. But let's remember that 3 is negative, so one of these has to be negative. It could be 1 and negative 3, or maybe negative 1 and 3. So let's start trying these out. So let's say that I chose 1 and 5 first. So that'll be x and 5x. And let's suppose that my first guess for negative 3 is 1 and negative 3. So plus y and minus 3y. So when you look at these products, you get 5xy minus 3xy, which is 2xy. You can see quite clearly that's not what you wanted. Okay, so that's not, it's not this one. But when you're checking these, make sure that you also check it the other way, because it still could be 1 and 3, or 1 and negative 3, but maybe you just need to swap the locations of those. So if you do it this way, maybe you're going to get negative 15xy and positive xy, and you can see that actually does work. Okay, so this is the correct factorization. Moral of the story is, make sure you, if it doesn't work one way, that you flip it and try the other way. Lastly, you can, if you're looking at this and you're saying, okay, well, 14 is awfully close to 15, so probably I should have positioned it so that I would get a 5 times 3 in there somewhere. And you can see that the way that we positioned this, we did end up multiplying the 5 and the 3.